Hello everyone, I'm Frank and welcome to Frank Puzzles, and this is today's easy level puzzle. And take that easiness with a grain of salt because it's considered easy by the people on the Logic Masters Germany forum, and there's a lot of really smart people there. Today's puzzle is called Roman Whisper Loop, and it's by Yitrio. And here are the rules. We have normal Sudoku rules apply, which means in every cell in the grid, place a single digit from 1 through 9 such that there are no repeats in any row, column, or designated 9-cell region, which is a box. We also have to draw a 1-cell wide loop of orthogonally connected cells. The loop may not touch itself, not even diagonally. So another way of putting it is that every cell on the loop must share two and only two edges with another cell on must share an edge with two and only two other cells on the loop. So this is a valid example of a loop because every cell on the loop shares exactly two edges with other cells on the loop. Shares an edge with exactly two cells on the loop. That's probably a better way of putting it. And you cannot touch diagonally, which means if it doesn't, I don't know how to describe it, but basically this is considered not touching diagonally because these are both connected to another cell. But if you went something like this, I guess you still have not this one. You still have that. This is not a valid loop because it would be touching itself diagonally. Obviously, if you had something like, I don't know, something like this, I guess, this would not be valid, right? Because it would be touching itself, right? So if it was trying to go like this, it would be considered touching itself. Because and another way of putting it would be that it shares an edge with three other cells on the loop, which is not allowed. And the loop acts as a German whisper loop, hence the whisper part of the Roman whisper loop. So the loop is basically the loop rule. The whisper part is the German whisper line, where adjacent digits on the loop must have a difference of at least 5. So, for example, if this were a 3, these two cells would have to be 8 or 9, because those are the only digits which are 5 away from 3. And that's an example of how the German whisper loop line or loop works. And we have XV, which are the Roman part of Roman whisper loop, right? Because these are Roman numerals. Digits separated by an X must sum to 10, and digits separated by a V must sum to 5. And not all possible X's and V's are necessarily given. So, for example, if this were, say, a 3, this would have to be 2. If this were, say, a 3, this would have to be 7. Because these two digits must add up to 10, these two digits must add up to 5. And that's an example of how XV works. And finally, for each X and V, there is at least one of the digits touching the X and V must be on the loop. So this loop actually doesn't work because one of these digits must be, that's touching the V here, must be on the loop. One of the X's here must be touching the loop, must be on the loop. One of the cells surrounding this X must be on the loop. One of the cells surrounding this V, at least one of the cells surrounding these V's and X's must be on the loop. And those are all the rules. If you'd like to play along, there's going to be a link in the description. And now, I'm going to get started. Let's go. So all the V's must be 1 through 4. Okay. Obviously, both of the V's can never be on the loop. And the reason why we know that is if it were on the loop, they would have to share an edge. So adjacent digits on the loop must have a difference of at least 5. Well, you'll never have a difference of 5 between two digits that add up to 5. So that's obvious going to be... So only one of the digits on the 1, 2, 3, 4 can ever be on the loop. Well, if it were here, the problem if that is that this can't be on the loop. So if we tried to go in, it has to go something like this, which would be then touching itself. So this cannot be on the loop. We're going to mark them gray. This must be on the loop, so we're going to mark this as blue. And we're going to alternate between blue and red on the loop, because we know on a German whisper line, if you have a low digit, it must be next to a high digit on the loop. And a low digit is 1 through 4. Excuse me, just something caught in my throat. And a high digit is 6 through 9, right? Because what digits can be next to 1 through 4 on a German whisper line? 4 can be next to 9, 3 can be next to 8 or 9, 2 can be next to 7 through 9, and 1 could be next through 6 through 9. So any digit from 1 through 4 must be next to a digit from 6 through 9. And it goes vice versa, too. 6 can only be next to 1, 7 can be next to 1 or 2, 8 can be next to 1, 2, or 3, and 9 can be next to 1 through 4. So any digit from 6 through 9 has to be next to a digit from 1 through 4. So anything on the loop, so first of all, we know both of these are on the loop because it's a loop, right? So you have to have any cell on the loop has to share an edge with exactly two other cells on the loop. So it must be these two. This can't be on the loop. This must go this way, so this is blue. And you sort of have this sort of checkerboard pattern anytime you have a loop which alternates between sets, right? So because of that, any possible cells that are on the loop would have to be here, would be even, right? To get to here, it would be alternate low, high, and low, right? And that's for any set, right? Because you have to go low. Since you can't travel diagonally, you have to go orthogonally, which means going vertically or horizontally or going through edges. You have to go this way, essentially. So all of these have to be high digits to be on the loop. So we're going to mark them as red. And all of the other ones to form a checkerboard pattern must be low, right? Because any way that you get, if you're on the loop, as long as you're on the loop, it'll always alternate between lows and highs, right? So this will be low, high, low, high, low, high, low, high, low, high. So every other one must be part of the same set, right? To be on the loop. So these have to be high, these have to be low, these have to be high, right? Because you'll always alternate between lows and highs. And this is only if you're on the loop. These are lows. These are highs. These are lows. These must be high. I guess we'll continue. We'll just mark these. So again, it forms like a checkerboard-like pattern, right? So these all have to be lows to be on the loop. Well, that gives us important information, particularly for actually for V's and X's. We know every pair of V's and X's has at least one digit on the loop. And if it's an X, if this is 1 through 4, if this is on the loop, it's 1 through 4, right? It has to be low. That means this is 6 through 9. If this is on the loop, it has to be 6 through 9 on the loop, which makes this 1 through 4. So you'll always know, so the X's must conform to exactly what the colorings are. This is high and this is low. Same with this. This is low, this is high. Same for all the X's. This is low, high, high, low. For the V's, though, any digit that is in a high position can never be on the loop Because, again, like I said, you'll always alternate between lows and highs, and if it ever goes to essentially a high cell here, if it gets to here, it would have to be low, high, low, high, low, high, low, high, low, and high. Well, this can never be a high digit, so this is never on the loop. Same with this. This is never on the loop, and this is never on the loop. So we know exactly which ones can be on the loop. This for the V's. Therefore, this must be on the loop here. So these are both on the loop. This can't be on the loop because it would be touching itself if that's the case. So it must go here. That means it continues here to be on the loop. So we can stop color. Okay, so we can remove the colorings except for the ones that we actually know. Right? Because we've gotten all the information that we sort of need from that. So these could be either. This has to go this way. We don't know about these. We don't know about these. We don't know about these. Or these. Or these. So we're going to move all the coloring. We do know about this. These have to be on the loop, and these have to not be on the loop. Well, since this must only share an edge with two cells that are on the loop, it has to be these two cells. So therefore, that goes this way and this way. This shares two cells, but it can't go here because then it would be touching itself because it would be going like that. So this can't be on the loop. This must be on the loop, and it must go this way. So this is on the loop. This is on the loop. How about this cell? Can this ever be on the loop? It can't enter and then exit again. So no, this cannot be on the loop. So it cannot go this way. So it cannot avoid this being on the loop. So this must be on the loop too. We don't know if it goes this way or if it goes this way though. So this must continue on this way. So that's fine there. Either of these could be on the loop. This is next to two unique digits on the loop. So this cannot be a 4. This must be next to two unique digits on the loop. So it cannot be a 4. So we have 4 digits in row 9, which are 1 through 4 then. That means the remaining digits in the row cannot be 1 through 4. So this would be odd. Sorry, this would be low, high, low. But this cannot be low here. Right, the rest of column, this is on the loop, so this is and it has it's next to two unique digits on the loop, so this can't be 6. These are 5 through 9. If this were on the loop, it would have to be low, so this can't be on the loop then. So, to not touch itself here, this has to go this way, and that's guaranteed. So this is high, this is low, this is high, this is low. And then it could go that way, it could go that way. We don't know. So this can't be on the loop. This must exit out this way. This is not on the loop. So this is between two, actually just not between two unique digits. It can never be 6 and 4 here though. So this can't be 6 or 4. This is next to two unique digits on the loop, so this can't be 6. Therefore, we have a 1, 2, 3 triplet in row 9 and a 7, 8, 9 triplet in row 9. That eliminates 1, 2, 3 in the rest of the row and 7, 8, 9. So these can't be 7, 8, 9 here. This can't be 2 or 3. Therefore, this is 4. This is 1. This can't be 1 here. This can't be 1 here. This can't be 1 here, so this can't be 4. This cannot be, so whatever digit is here, it's next to two unique digits on the loop, right? The loop has to continue. It doesn't stop. So it either goes this way or it goes this way. So this cannot be 4, therefore this can't be 6. This is similarly next to 2 unique digits on a loop. It either goes this way, which means those two cannot be the same digit, or it goes this way, which means those two can't be the same digit because they're in the same column here and the same box here. So this must be 2 and 3 here. This is 5 or 6. This is 2 and 3, must add up with 7 or 8. And it cannot be 7, 3 to be on the loop, because 7 and 3 have a difference of 4, which is not allowed on the loop. So this is 8, this is 2, which makes this 3 and this 2. That's 3 in the corner. 3 in the corner can only be next to 8 and 9. This can't be 8, though, so this is 9, which makes that 8. That means this can't be 8, so this can't be 2 here to add up to 10. This cannot be a 2-3 pair. It's 1 and 4. Only 1 can be between the 2 unique digits on the loop. So this is 1. This is 4. This could be... This digit is going to be next to 2 unique digits on the loop. It goes either here, here, or here. But these all see the same cell as this one. So this is 7, 8, or 9. It cannot be 6. This can't be 2 and 8. This cannot be 4 and 6, so this is 1, 3, 7, 9. Okay, this can't be 8 or 9. This is 7, so this can't be 7 here. This can't be 1, therefore this can't be 9 here. This can't be 2, so this can't be 3, because these add up to 5. If we go this way, then this way. What does that mean? So if we go this way, we have to go this way. That would mean this is 1 and 9. And then this, having to be a low, cannot be 2 and 3 or 1. It would have to be 4. But this 4 would have to be between 2 unique digits. It would have to go that way, because you can't go that way because it would touch itself. So this 4 would be between 2 unique digits on a German whisper loop, which is not allowed. So it cannot go this way. Therefore, it must go this way. Cannot go this way because it would touch itself then. Can't go this way because it would touch itself anymore, because now it can't actually exit out from here. This must be 7 or 6, 7, or 8. But if it were 2... Whichever way it goes, whether it's here or here, it's next to 2 unique digits, so it can't be 6. This is next to 2 unique digits, 7, 8, or 9. This is next to 2 unique digits on the German whisper loop, so it's 7, 8, or 9. This cannot go this way because then it would be touching itself there. So it goes either here or here. We're not sure which. What else do we know? Okay, this cannot be 6 here. If this was 6, it could technically go there, but that would have to be 1. And so this is not allowed. So this is a 7. Therefore, this can't go here because the 7, 8, and the 9 are removed, and the 2 can only be next to 7, 8, or 9. So this must go this way then. Again, this can't be 6 because while you could have had a possibility for this being 6 and this being 1, 1, the 1 in this row here eliminates that possibility. Oh, this can't be 1 or 4. This must be 2 or 3 here. This is 7. If it went here, the low digit would have to be a 4 because we have 1, 2, 3 in that box. So this must go this way. And it cannot be 1. It must be a 2. So this is 2, which makes this 3. That makes this a 1, 9 pair. It cannot connect here because then it couldn't be as either of these cells here, and it must connect to one of these. So it cannot connect this way. Okay, so the reason why I can't do that is that if it went again here, that would be touching itself, considered touching itself. So it can't go this way. It must enter this way. It could just go across here. That's fine. This is not on the loop. This is not on the loop. because it would be touching itself. This is 7 or 9 because those are the only digits that the 2 can be next to. Because 8 is ruled out. This must be a 4, 5, 6 triplet. This can't be 4, though. This 9 eliminates 9 here, so this is 8. Remaining digits in row 8 are 5, 6, and 9. This can't be 9. This is 5 or 6. Ugh. I'll eventually click on the right digit. Therefore, this is a 9 here. This is not on the loop. This could be 3, 5, or 6. This could be 3, 5, or 6. So one of these is a 3. This digit must be a 7. That's the only possibility. Okay. Oh, yeah, it has to go this way. So this is high. Can it go this way? It's still possible. It doesn't have to go this way. It's likely that it goes this way, but it doesn't have to. Oh, wait. No, it does. If we try to go this way, it would touch itself here. So it cannot go this way. So that must go here, which means none of these can be on the loop because it would be touching itself. This must share edges with 2 cells in the loop, and these are the only 2 cells available now. Because this can't be anymore because it would be touching itself. So it either goes this way or it goes straight into it. This cannot, it's next to 2 unique digits, guaranteed, so this must be a 9. This is next to, well, we don't know if it's 2 guaranteed digits, so this could be 6, 7, or 8 here. This is guaranteed to be a 9. This cannot be on the loop because it would be touching itself. This is 2, 3, or 4. So since this can't be 1 here, this can never be a 7 then. 7 has to be between only 1 and 2, and neither of these could be 1. Okay. What else do we have? It goes up here. So it goes like this or this way. So either way, this can never be on the loop. It must enter here or here. So it could go something like that. No, it cannot go something like that. So say it does not enter here. If it does not enter here, it would have to go something like this. But you would have 2 high digits here if that were the case. So this must always enter this cell then. We don't know if it enters this cell. It can't. Because if it goes this way here, it can't exit back out without touching itself. So this does not on the loop. You can't do that because it would touch itself, so it must connect here. So these cannot be on the loop because it can't enter and then exit back again. This has to be in between. This is between 2 unique digits on the loop, so it can't be 4. So is this. This is between 2 unique digits. It's 1 and 3, but this can't be 3. Because if this were 3, it would have to be at least guaranteed next to a 7, which is not possible. So this is 1, this is 3, this is 2. 3 can only be next to 8 and 9 on the loop, so this is 8 and 9. This can't be 3. Therefore, 3 must be here. If this were on the loop, it would be next to a 9, but this can't be 8 or 9, and this can't be 8 or 9 because of the 8 and 9 in the box. So this cannot be on the loop. Therefore, this is on the loop, and these cannot be on the loop because then it would touch itself. This cannot be 3, can't be 1, it must be 2 as the remaining digit between 2 unique digits on the loop. This can't be 8, so this can't be 2 here. This could be 6 or 7. If it goes up, though, this digit would have to be a 4 because we have 1, 2, 3 in the column, and it can't have that. 4 can never be next to 6 or 7 on the loop, so this is not on the loop, which means it goes this way, so it must connect to one of these 2. These then can't be on the loop. This can't be on the loop because it would be touching itself. This can never enter in here because it can't exit out without touching itself. So these are not on the loop. This cannot be 2. It could be, can't be 4 because it's next to a 6 or 7. So this is guaranteed to be a 1. That means this can't be 1. This is 3. This is 7 to add up to 10. This must be 1 and 4 to add up to 5 because 2 and 3 is no longer valid. This 7 eliminates 7 here, so this is 8, which makes this 9. This must be 9 to be next to the 4 on the German whisper loop, so this is 9. This cannot be 4. This is 2 or 3. Okay. This 7 and 3 eliminates 7 and 3 here, so this must be 6 and this must be 4. That 6 eliminates 6 here, so this is 5 and 6. 5 eliminates 5 here. This 6 means this can't be 6. This is 5, which makes that 6, which makes that 5. This 4 eliminates 4 here, so this is 6 and 4. This 7 eliminates 7 here, so that's 9. Can this go here? If it goes here, this would have to be a 4 because it can't be 1, 2, or 3. So this cannot be on the loop. It must go this way. And it cannot be 1, cannot be 3. It's next to an 8, so therefore it's guaranteed to be a 2. One of these is on the loop, and it could connect here, I guess, too. We don't know. Okay. Can it go here on the loop? Now, the remaining digits on the loop in the column 2 are 6 and 7. So it cannot go this way because that would be a low digit expected on the loop. So it must go this way. So this is on the loop. It cannot be 2, 3. It's next to 2 unique digits on the loop, so it must be 1. This digit, if it were on the loop, would have to be a 6 because it can't be 7, 8, or 9, and it has to be a high digit. So this cannot be on the loop because it would be next to 1 and 2. This is not on the loop. This is on the loop, and it must be a 7, which makes this a 6. Okay, what about if we go this way? What are the remaining digits in... Well, let's do the remaining digits in row 2, because this is helpful. 2, 5, and 8. Okay. 2 cannot be here. 5 cannot be here. Remaining digits in column 7. We have 4 and 7 remaining. This can't be 4 because of the 4 in the row. So this is 7, this is 4. Remaining digits in column 1. We have 4, 5, and 6, and neither of these could be 4 because of the 4 in the box. So this is 4. That makes this a 5, 6 pair, which means in that box we only have a 2 remaining for the final cell. So that's 2. That leaves these digits as 3, 5, and 8. This can't be 8. This can't be 3. Column 8. What are the remaining digits? We have 5, 6, and 3. 3 can't be here. 6 can't be either of these. So this is 6, which makes this a 3, 5 pair. That means, since this is a 3, 5 pair in box 3, that eliminates 3, 5, and 8 in the rest of the box. Sorry, 3 and 5 in the rest of the box. So this can't be 5. We have a 2, 8, 2, 8 pair in row 2, which eliminates 2 and 8 in the rest of the row. So this must be a 5 because it can't be 8. Rest of box 6 is 1, 5, and 7. This can't be 1 or 7 because of the 1, 7 in the row. So this is 5, which means this can't be 5. This is 8. So that can't be 8 here. That leaves 1 and 7 remaining here. Rest of column 9 must be 2, 8, and 9. This can't be 8. This can't be 2 or 8, so this must be a 9 here. Therefore, this is a 2, 8 pair here. Rest of column 6 is 4, 5, 6, 7. Okay. Well, this can't be 4, 5, or 7, so this must be 6. Which means none of these can be 6. This can't be 6. This cannot go this way, because if it did, 6 would be next to 2 unique digits on German whisper line, which is not allowed. So it has to go this way, which means this is a high, so this is 8. And it makes it 2 or 3. That's fine. This 8 eliminates 8 here, so that's 2. This is 8. This 6 eliminates 6 here, so it's 5. This is 3. This can't be 3 because of the 3 in the box, so it's 5. This 3 eliminates 3 here, so that's a 2. This can't be 5 here. This can't be 4. This can't be 4. Where is the 4 in column 6? It must be here. So this is 4. We're just doing now normal Sudoku. This 5 eliminates 5 here, so it's 6. This is a 3-7 pair here, but this can't be 7 because of the 7 in the column. So this is 3. This is 7. Rest of column 4. Actually, let's do rest of row 5. We have 6 and 4. 4 cannot be here because of the 4 in the column, so this is 6, this is 4. That leaves in column 4, the rest of the digits are 1 and 8. 8 cannot be here because of the 8 in the row, so this is 1, that's 8. This 1 eliminates 1 here, so it's 7, 1. 7 eliminates 7 here, 5 and 7. 5 eliminates 5 here, so it's 3 and 5. That leaves this as a 9 and this as a 3. And that's how you solve it. Yeah, pretty straightforward. For a loop puzzle, this is actually, yeah, fairly easy. So I would definitely classify that as an easy puzzle. Because it's pretty straightforward. You just have to basically understand the logic behind essentially German whisper loops and loops that can touch itself, the geometry of essentially loops. And then it's pretty straightforward from there. Particularly the geometry of how things alternating set loops, essentially. That gives us a checkerboard pattern, which allows us to easily see what cells can and cannot be on the loop, and what the X's were. So that was actually very cool. I don't think I've ever done anything like that with these type of puzzles, but it's always been something that's sort of in the back of my mind. And I got to use it today, which is nice. Anyways, I hope you enjoyed this solve, and I'll see you next time on Frank Puzzles. Take care.